now this one is similar to the last one that we did. I want to find the tangent of the angle whose sine is negative 5 over 6. Now again, I can do this without a calculator. I can do this without a calculator. But this time I can't just draw any old triangle because the sine of this angle that I'm looking for is negative 5 over 6. So I have to put this in the correct quadrant. Okay? So I have to think about, I'm going to draw one of these 4 triangles. Okay? I'm going to draw one of these 4 right triangles. Isn't that a cute bow tie? Okay. So I need to pick what quadrant. So now when you're dealing with the sine, so this is going to be our angle. That's going to be our angle. Okay? So I need to pick which quadrant is going to have, well, which 2 can I eliminate? Okay, this is a plus plus, that's gone. And what are all the ordered pairs over here? Minus minus, so that would, these will be positive values. These would have positive fractions here. So it's going to be one of these 2. So now sine, isn't that opposite over hypotenuse? Opposite over hypotenuse. Now isn't the hypotenuse is always positive. Doesn't matter what quadrant. So where is the opposite side to this angle negative?
Quadrant 4.
Quadrant 4, right here. Someone said that a long time ago, didn't they? So this quadrant right here will have, this side is negative 5 and this side is 6. So this angle alpha right here have a sine that is negative 5 over 6? This is saying what angle has a sine value of negative 5 over 6? So alpha is the answer to that. So how did I answer this question?
Alpha.
Alpha is the answer to that. So now I just need to find the tangent of alpha. So what is the side ratio for tangent? Opposite over adjacent. So tangent is opposite over adjacent. So I know the opposite side, but I don't know the adjacent side. How am I going to find it? Pythagorean theorem. You always use the Pythagorean theorem to find the third side in a right triangle. So a squared plus b squared equals c squared. So let's see, that'll be a squared I'm looking for plus what's negative 5 squared? 25 equals what? Okay, what's c in the problem? And what's 6 squared? 36. So now, get a squared by itself. What does a squared equal? 11. And so a is square root of 11. So the adjacent side is square root of 11. So what is the tangent of alpha? What's my final answer? Negative 5 over square root of 11. You can rationalize that if you want to. I don't know if Bob has it rationalized, but I'd be okay with that. I hope you know who Bob is. Okay. All right, are you ready for a fun one now? That was not fun enough. We need more fun in our lives. Okay? All right, so here we go. Directions here. Write the expression in algebraic form. These are the directions as stated in your homework. Writ the expression. Okay, write the expression in algebraic form, and here is our expression. Our expression is the cosine of the arcsine of x minus h over r. I picked the hardest one I could. I could make it harder than this, but I won't. Okay, so now the directions might make you think that it's different than the other problems that we did, but doesn't this look similar to other problems we did? Except instead of having a number over a number, we have variables. So isn't this still asking us for what angle has a sign equal to x minus h over r. That's the only difference. It's still asking us the same question. So can we answer that with a triangle? Can alpha be the answer to that? Yes. This is going to be answered with angle alpha, or whatever you want to name it. So I'm going to make myself a right triangle. And this time it's nice because it can be wherever I want it to be. So there's my angle. I want this angle to have a sine of x minus h over r. So which side related to this angle needs to be x minus h? Opposite. Isn't sine opposite over hypotenuse? Okay. So you never thought you'd be doing this in calculus today, did you? Remembering the basic trig functions? Here they are. Okay, so x minus h over r, the hypotenuse is r. Okay, so now we answered this with alpha, so now what do I need to figure out about alpha now? The cosine.
We call it fishy.
Call it fishy. I'm going to call it alpha though. Okay, so now, what's the cosine ratio? Opposite? No. Adjacent over hypotenuse.
See what happens when you come in late?
I know. I'm not focused. I'm wearing my hat and I'm not supposed to be. Jeez. Okay.
He's got the hat on.
Me. Okay. So, how do I find that adjacent side? Pythagorean theorem. Okay, it's not that hard. So let's call that, what do we want to call that side? A for adjacent, capital A. Okay, call it whatever you want. Call it happy face, square. Okay, so is it capital A squared plus quantity x minus h squared equal to r squared? So let's get A by itself. So how do I start to get A squared by itself? How do I move this to the other side? You subtract it. So I'll have r squared minus x minus h squared. And then how do I get rid of the squared? Square root. So A, the thing I'm looking for, is the square root of, this side here is the square root of r squared minus x minus h squared. Please don't try to do a bunch of stuff with this. That's not necessary.
Don't try to use the absolute value quotient.
No, don't, please. So now, don't we know all three sides now? So we could find any trig function we wanted to. But we only need the cosine of this angle. So the adjacent side is what we just found, the square root of r squared minus the quantity x minus h squared. Over what? R. And I'm done. Is this an algebraic statement? There we go.
Indeed.
Indeed. Okay, so now this brings us to one more thing. Let's say I was asked to solve this equation. This is still little review of pre-calculus. So solve.
Are we doing any calculus today?
Yes. So we would like to solve this equation. The arcsine of the quantity 3x minus pi equals 1/2. So what are we trying to get by itself then? The x. So I just use inverse operations. Very good. I want to get rid of the arcsine, I take the sine of both sides. So I'm going to take the sine of the arcsine of 3x minus pi equals the sine of 1/2. Okay, so what is the sine of the arcsine of 3x minus pi? It's 3x minus pi, because the sine and the arcsine being inverses cancel. Just like subtracting and adding a number cancel each other out, right? That's what inverse operations do. So now I have 3x minus pi equals the sine of 1/2. Okay, now what?
Log them in.
You add pi to both sides. So you're going to do that whole thing and then add pi. And then how do you get rid of times 3? Divide the whole thing by 3. So I'm just going to get my calculator out. I'm going to find the sine of 0.5. I'm going to end the parentheses, because that's the only thing I need to find the sine of, plus pi. Find out what that equals, and then divide that by 3, and I get that x is equal to 1.207. Just make sure you're in radians, because you're finding the sine of 1/2 being a radian measure of an angle. Okay, so now we're ready to learn the derivatives of the inverse trig functions. Now we're ready to learn the derivatives of the inverse trig functions.
Oh, calculus nonsense.
Well, I can show you exactly where this came from. No? Well, basically, if you're talking about the arc sine of u, the angle whose sine is u, you can draw a triangle whose opposite sine is u and whose hypotenuse is 1. So you can draw this triangle. There's my angle alpha. The sine of it needs to be u, or u over 1. So the opposite side is u, the hypotenuse is 1, and so wouldn't this last side be the square root of 1 minus u squared? So they come up with, that's how they get, that's where the derivatives come from, is by drawing triangles like we did. So I won't do a proof. Instead, I'll just show you how to find derivatives. So let's look at a couple of examples here. So find the derivative. So now we've got these 6 rules, okay? We've got all of our other rules. There's a fabulous page in your book. Page 376 lists every derivative rule in chain rule form, every derivative rule that we know so far.
That's 24 of them. I copy them all down here.
24 of them. Nope, I would just refer to this page whenever you need to. By the end of the chapter, you will have a page with all kinds of derivative and integral rules on it that you can use on the test. So I'll give that to you. So let's say we want to find the derivative of, let's see, f of x equals the arctangent of the square root of x. So we want to find the derivative of the arctangent of the square root of x. Okay, so first thing I want to do is I want to write down the formula that I'm going to use. So what's the derivative of the arctangent of x equal to? The general format of this, I'm going to go up here and look at my, it's going to look like this. It's going to look like u prime over 1 plus u squared. This is what my derivative of this is going to look like. So I need to figure out what's the u. What's the u? What am I taking the arctangent of? Square root of x. So u is the square root of x. So in order to get my derivative, I need to find the derivative of that. So I need to find u prime. So how do I find the derivative of the square root of x? Write it as x to what power? 1/2, and use the power rule. So multiply by 1/2 and subtract 1 from the power. So what power do you get? Negative 1/2. So I can write u prime is 1 over 2 radical x. Yes?
Yes.
I would memorize that derivative. The derivative of the square root of x is 1 over 2 square root of x. It's the same every time. Okay, so now I can plug this right here is going to go where in my derivative? It's going to go on the top. It's going to go on the top. That's where u prime is. So 1, now in this, if it all goes on the top, it's really the same as the 1 going on the top, and the 2 radical x can end up on the bottom. Times 1 plus, what's the u? U is the square root of x. So if I put the square root of x in and square it, what's the square root of x squared? X. Now, is there really anything I can do to simplify this?
No.
I mean, I could distribute, but that will not make it look, this looks nicer than distributing it. So this is it. You're done. There's your derivative.
Yippee!
Yippee is right. Okay, we'll look at a couple more of those.